In this second of two movies, we're looking at messages in communication diagrams. We've already briefly looked at the difference between communication diagrams and sequence diagrams, and at lifelines and the links between them. In this movie, we'll look at the format of messages in communication diagrams. Messages are shown in communication diagrams alongside the links between lifelines. Alongside the name of the message, there's a short arrow, and the style of the arrow relates to the type of message that it is. A creation message results in the creation of a lifeline and is a dashed arrow with an open arrowhead going to the rectangle. A synchronous message represents a synchronous call, usually of an operation of the class of which the lifeline is an instance. A reply message represents the return from a synchronous call and possibly the return of results. Replies are less used in communication diagrams than in sequence diagrams, as they can make the diagram very cluttered. An asynchronous message represents an asynchronous call, usually of an operation of the class of which the lifeline is an instance, or a signal. Here's a diagram where you can see the message names and arrows alongside the links. You may have noticed in the previous two slides that all the messages have some kind of numbering. This is because in a communication diagram, the sequencing of messages is shown using this numbering system. Time doesn't flow down the page as it does in a sequence diagram. The numbering isn't well defined in the UML specification, but in formal terms it looks something like this. In practice, this means that each message is preceded by a sequence expression that allows the reader to determine the order of the messages. You can just number them 1, 2, 3, and so on, or you can use dots to separate additional levels of numbering. For example, 1 followed by 1.1, 1.2, 1.3, and then 2 followed by 2.1 and 2.2. Where there's going to be an iteration of messages or a conditional sending of messages, you can include a condition in square brackets with an asterisk first if it's an iteration. We'll look at these in more detail in another movie. In the early stages of a project, typically during analysis, the names used on messages can be informal, reflecting the fact that the operations may not have been defined, but the analyst has an idea of what the intent of the message is. For example, a message requesting the change of dates. The formal syntax is shown here and is available in the UML specification. What this means is that a message is either a request message or a reply message, or the asterisk that represents a message of any type. Again, here's the formal syntax of a request message. Usually it's a call of an operation on the target lifeline and may include argument values or the names of the arguments and their values. So here, the message represents the change dates operation of schedule, with the start date and duration. Reply messages are often left out, but here's the formal syntax again. What this means is that you can show the assignment of a return value to an attribute or variable if it's useful to do so. Let's have a look at messages in the model in EA. Here's the communication diagram for Add a Device that we started in the previous movie. I want to add some messages into this. We'll start with the creation message going from the actor to controller. I right-click on the link between the two lifelines, and you can see that there are two menu options for adding a message, one for each direction. I'll choose the first of these to go from engineer to controller. The message is added alongside the line on the diagram. Now I want to give the message a name, which is going to be the constructor for Add Device Controller. So I double-click on the message itself. I can select the constructor from the operations of Add Device Controller. Unfortunately, there's a bug in EA which means that I can't change the lifecycle to new for a communication diagram in the same way as for a sequence diagram. So I'll leave this as an ordinary synchronous message. If you're using another tool, set it to be a creation message. I'll add a message in the same way for the message going to Add Device GUI using its constructor. I select From Controller to GUI. Again, I can select the constructor from the operations that have already been defined. And if I was going to change the life cycle to make this a creation message, I would select New from the drop-down list here. Now, the first thing that the GUI does is initialize itself by sending the message initialized to its own lifeline. In order to do that in a communication diagram, we need to show a link that goes from the GUI object to itself, which I haven't added yet. I can add that by drawing a link from the GUI to itself using a quick linker. And I select Link from the menu of options. I need to add the message initialized to this link. So I do the same as I did before. I right-click on the link, select Add Message from GUI to GUI, and then I set the name of the message and position it appropriately on the diagram. I'm to keep the flow of messages simple here by creating a message called enter values from actor to GUI, followed by one called submit. So enter values represents the entry of the name, the type, and the address. At this point, it's worth stopping to look at the numbering. By default, EA numbered the first message 1 and has numbered the messages after that 1.1, 1.2, 1.3, and so on. We'll leave it as it is for now, but I'll show you how to change the numbering in the next movie. There's now a submit message that goes back to the controller and a get values message to the GUI. Finally, there's a message to the device using the constructor on-off device. It's worth comparing this with the sequence diagram. What I've added so far in the communication diagram is equivalent to the first part of the sequence diagram, to the point where the on-off device is created. I've simplified it somewhat by using enter values instead of the 3 messages for name, type, and address. Let's go back to the communication diagram. So, in this movie, we've added messages to our communication diagram. In the next, we'll look at how you can show loops and alternative paths.